Hello, everybody. So today we will start another session of C Sharp. So let's see what we have in store today. Okay. Okay. So the objectives of today's class are building blocks of .NET platform. I think last time we'll see building blocks of .NET platform, the CLR, CTS, and CLS. The binaries, and we'll see .NET namespaces. So what did we do last class? So last class we saw the philosophy of .NET, what the previous state of affairs were, how was life as a C or a C++ programmer, as a VB programmer, as a Java programmer, and as a COM programmer. We saw their merits and demerits, and why C Sharp really came into existence. Uh, so we'll take a look. So now you can have the C Sharp. This is a C Sharp solution here, and what the language had to offer. So as far as pointers were concerned, no pointers were needed, right? Just like Java, and we don't have to manipulate with pointers at all. So next is memory management, right? So we don't. There is automatic memory management in the form of garbage collection. So that's about C Sharp. And as far as the delete keyword is concerned, so C Sharp does not support a delete keyword. So uh, I mean, we don't have to bother about freeing memory as such, correct? It is all taken care. So, and as far as syntactic constructs are concerned, we have enumeration, we have structures, we have class, properties, correct? Then as far as C++, C++, we all know is an object-oriented language. So it has the ability, C# has the ability to overload operators. Then interface-based programming. So C# does fully support interface-based programming as well. So next, let's see the building blocks of the .NET platform. Okay. So just did that just in case I'm not too audible. So next is the building blocks of the .NET platform. One is first is the CLR, that's the Common Language Runtime. Then next comes the CTS, Common Type System, and the CLS. So when we mean by okay, so let's first take a look into CLR. Okay, I think that slide is missing. Okay, so what is CLR? CLR is the common runtime layer, which is referred to as CLR. The primary role of the CLR is to locate, load, and manage .NET types. Okay, so what do we mean by .NET types? That's I have mentioned it here. So what's a .NET type? So we all know that C# is a strongly typed language. That means to say that every variable and a constant has a type. it evaluates, so every expression evaluates to a particular value. So a typical C# program uses types from a class library and as well as user-defined types. So so what do we get from a type? So the information stored in a type, what does it have? The storage space, correct? So we can know exactly as to how much of storage the type can have. Then the maximum and the minimum values. So we know that if it's an integer, it's a floating point, how many bytes can it have? What's the maximum? So it's like if it's an integer, it's like 2 raised to 4. That's 0 to 2, 0 to 16. And if it's an unsigned, it can go from minus some particular number to plus some particular number, correct? 2 raised to unsigned, I think, is 2 raised to 10, 2 raised to 16, sorry, 2 raised to 16, because 2 raised to 4 is 16. So things like that, minus 3 to 6 something, correct? So that's about the maximum and the minimum values, right? The 2 raised to 16 minus 1 to 2 raised to 16, 2 raised to 16. Then what else does a type tell us? The member methods, fields, events, and so on. So then when we know the type, we know the base type it inherits from. For example, if it's an int, what do we know if it's an int? We know that int inherits from system.int32, which inherits the value type, and which in turn inherits the object type. So knowing all this information, the compiler makes use of this information just to make sure to see that all operations performed are type safe. Now, what do we mean by type safe? Now, let's say, for example, we have a code snippet here, int a is equal to 5, b is equal to a plus 2. We know that this is fine. Now, this is a Boolean variable, right? Test. Now, if I try to add a plus test, we know that the compiler is not fine with it. So that is what we mean by type. Okay. So we also have types like built-in types, custom types, and there are others too. Let's not get into that, like generics and anonymous. Right? So next is we'll come to CTS, the common type system. So what is the common type system? The common type system, it describes all the possible types, all the possible data types, in fact, and programming constructs. So data types we know. So programming constructs is if else and all the loops, things like that. So supported by the runtime. It also specifies how these entities interact with each other, and it also specifies the CTS. It also specifies how they are represented in the metadata format. We'll take a look into metadata manifest a little later. Okay, it'll become a little more clear as we go a little deeper. Next, so this is next is CLS. So there we have just mentioned the basic building blocks. We are just trying to define what CLR, CTS, and CLS is. We'll take a look at it a little more in detail. Okay. So what is the CLS to begin with? CLS defines a subset of common data types and programming constructs that all .NET aware languages should agree. Okay, let me repeat that. Defines a subset of common data types and programming constructs that all .NET aware languages can agree on or should agree on. So what does that mean? So that means the .NET type that exposes this CLS compliant features. Okay, the .NET type that exposes this CLS compliant features, they can be used by all .NET aware languages. We know that .NET can be can be programmed with many languages: C Sharp, VB.NET, C++.NET, things like that. Okay, but in turn, what happens? A type, a data type, or a programming construct which is outside the bound of the CLS. We'll take a look at it with the help of an example. Okay, may not be used by every .NET programming language. So what do they mean to say by that? A data type or a, like say for example, an unsigned int, probably that is not present in VB, maybe, or some other language, correct? So that since it's outside the bounds of the CLS, it will not be used by every programming language. Next. Okay. So let's take a look at the role of the base class library. So what is the base class library? A library, as we all must have guessed. So it's a functionality which is available to all .NET aware languages. Please keep in mind that when we say .NET aware, okay, so like C Sharp, VB.NET, etc. So we have libraries for you can take a look at the list there for file reading and writing, threads, then for IO, then GUI, database, XML, then security, and we can have construction of web-enabled pages. Okay, so that's the base class libraries for you on the top there. Okay, and here is the common language runtime, CTS and CLS. Fine. So this is what we just discussed: XML and web-enabled pages. Okay. So next, let us come to assemblies. So when take a look at what happens. So when the .NET compiler, in fact, the C# .NET compiler, it does not, when it's compiled, when a C# document or a C# code is compiled, it does not generate machine code, just like most other programming languages. In fact, it is compiled into an assembly. So you can see C# code, when it's compiled with a .NET compiler or a C# .NET compiler. Every language has its own compiler, correct? It does not have a common compiler. So it generates this particular assembly. So assembly, what does it have? Metadata and intermediate language. So let's take a look at .NET binaries. So what do we have? So first of all, we need to know that regardless of which .NET aware language we choose, whether it is C# or VB.NET or VC++.NET, okay. So C# .NET binaries take the same file extension. They take the same file extension, .exe or .dll. So, and we should also know that .NET binaries, they do not contain platform-specific instruction, but they have platform agnostic CIL. So that means to say they are a little on top, they sit on one top of the OS. So that means to say that when .NET binaries have been created using a .NET compiler, okay, when these binaries are created by a .NET compiler, the resultant module is bundled into an assembly, right? So that is what. So let me say that again. When .NET binaries have been created by using a .NET aware compiler, okay, the resultant module is an assembly. Okay, where is my pointer? So what's an assembly? An assembly is a logical grouping of one or more related modules. It's a logical grouping of one or more related modules, okay, that are, and what are those modules? That is CIL, where is that? CIL metadata manifest, okay, that are intended to be deployed as a single unit. So an assembly contains CIL code. So that means that's not that it need not be compiled to platform specific instruction immediately or until it is necessary. Okay. So now let's continue with the overview. See, when we say really necessary, here, when we say that it may not be compiled to platform specific instructions. So what do we mean by that is it's the point at which the block of CIL instructions are referenced. It's the point at which the block of CIL instructions are referenced by the runtime engine. Okay. So what does this assembly contain? It contains metadata. It contains metadata that describes the characteristic of every type which exists in the binary. It describes the characteristic of every type which is in the binary. So what else do we know about assemblies? Let's see, I mean the manifest, we'll see. Assemblies themselves are also described using metadata, which is in turn termed as manifest. So what does the manifest have? Name of the assembly or module, current version of the assembly, list of files, copyright information, and list of externally referenced assemblies. Next, so let's see, let's try to see what managed and unmanaged code is. So what happens is C# produces code that can be executed within the runtime, correct? We all know that. The code targeting the runtime and the .NET runtime is called as managed code, and the code which cannot be directly hosted by the .NET runtime is called uh, uh, unmanaged code. Okay. Okay. So now next what we'll see what .NET single file and multi-file assemblies are. Fine. When we uh, let's talk about single file assemblies first. First of all, a quick recap. What's an assembly? An assembly is a logical grouping of one or more related modules, right? So that it can be deployed as a single unit. So a single file assembly, it contains all the necessary CIL metadata and manifest in a single well-defined package. Okay, it contains all the necessary CIL metadata and manifest in a single package. On the other hand, multi-file assemblies are composed of numerous .NET binaries, each of which is called a module. The primary, okay, each of which is called a module. When building a multi-file assembly, okay, so when we build a multi-file assembly, one of these modules, which is termed the primary module, must contain the assembly manifest, and there could be some CIL instructions and metadata. So, fine. The other related modules contain metadata level manifest, CIL, and type metadata. Okay. So now more about multi-file. Multi-file assemblies, they are used when different modules of the application, when different modules of the application are written in different languages. Then why should we choose to create multi-file assembly? See, multi-file assemblies, they make downloading process more efficient. Okay, so they enable us to store the rarely used types in separate modules and download them only as and when it's needed. So whenever you need it, it will get downloaded. So that makes things very efficient. Okay. So next, let us take a look at CIL. So what is CIL? What is CIL? It's CIL is a language that sits above any particular platform specific instruction set. Okay, it sits above any platform specific instruction set. So regardless of which .NET language you choose, like C#, VB.NET, VB, the particular particular, okay, the particular compiler produces CIL instructions. So once the C# compiler, that is CSC, C# compiler. So once the C# compiler cxc.exe compiles the source code, you end up with a single file, start.exe. Okay. So assembly. So what's an assembly? That contains a manifest, CIL instructions, and metadata describing each aspect of the program. So let's take a look at some of the benefits of CIL. One is the language integration. So each .NET Aware performs the produces the same underlying CIL, right? It performs. So all .NET aware languages are able to interact. Now we know that CIL is platform agnostic, correct? So that means to say that the .NET runtime, it can be platform independent. So thus, CIL has the potential to allow you to develop. So what does that mean? If it's platform, you can develop C sharp, or in fact, you can develop applications in any language and have it run on any platform. Okay. So okay. Okay. So now let us take a quick look at the metadata, the role of the metadata. So metadata, it describes each and every type, that is class, structure, enumeration, defined in the binary, as well as the members of each type. Okay, so it also describes each externally referenced assembly. Okay, it defines each externally referenced assembly that is required by the executing assembly to operate correctly. Let me repeat that. It describes each externally referenced assembly. So what else are its uses? It is used in many aspects of the .NET. This one. It is used by some developing tools, by, you can see, by some browser utilities, debugging tools, and it is used by the compiler itself. And these are the other few things in which they are used: .NET remoting, reflection, and object serialization. Now let's consider a simple example. You can see that's a class calculator. It's adding two numbers. It's taking in two arguments. Okay. So when we find the when it's compiled and we find the meta info window, this is the meta info window. We don't need to really know too much of details regarding this, but the meta info window looks like this. Okay, so you'll find, when you find the description of the add method, when you find the description of one more, okay, you can see the fully when it's described by the C# compiler, it looks like this. Next, let's take a look at the role of the manifest. So assemblies, first of all, they are also describing metadata, which is termed as manifest. So I think we have come across this in the earlier slide. Let's go through this once more. So because this comes as a separate topic in itself. subtopic, in fact. So the manifest contains information such as name of assembly, okay, name of assembly or module. So current version of the assembly, list of files in the assembly, copyright information, and list of all externally referenced assemblies. And all these are necessary for proper execution of the program. Now, let us take a look at compiling the CIL to platform specific instructions. Fine. Okay. Assemblies, they contain CIL instructions and metadata, correct? That is, they do not contain platform specific instructions. They contain CIL instructions instead. Please remember, CIL is not platform specific. So it is converted to platform specific only when it's needed. So CIL must be, you can see here, it must be compiled on the fly whenever it's used, before use, in fact. So the just-in-time compiler, that is the jitter, is used to compile, okay, is used to compile the CIL into CPU instructions. So when developers they write a single body of code, it can be efficiently just-in-time compiled and executed on machines with different architectures. Correct. Now let's say, for example, if we are building an .NET application that is to be deployed onto a handheld device like a pocket PC, the jitter or the corresponding one is well equipped to run within a low memory environment. Whereas on the other hand, if we have a backend server, if we are deploying our assembly in a backend server, we know that it needs high memory, right? So jitter is well equipped to do that. What jitter will cache the results in memory in a manner suited to the target OS. Okay. Next comes the CTS. So what do we know about the CTS? So it describes all the possible data types. It describes all the possible data types and programming constructs supported by the runtime. So it specifies, okay. Fine. So what else? When we wish to, it specifies, it describes all the possible data types and programming constructs supported by the runtime. So it specifies how these entities can interact with each other, right? I think we have seen a brief preview of all these things. In fact, I'm just repeating this. So details of how they are represented in the metadata format, and it is used by, so when we wish to all .NET aware languages. So when that's said, that when we wish to build assemblies that can be used by possible .NET aware languages, we should conform to see to it that the exposed types, they agree to the rules of the CLS. These are some simple things which we have studied in our previous programming classes. Okay, like CL in class time. So it may be composed of what's a class? Composed of methods, constructors, data points, stuff like that, right? So class, it may be deriving from a single base class, right? And then let's take a look at this small snippet of code. So you can see that it begins with the keyword this one, and that's how this class is. It adds two numbers. So some small things that we need to know. What's a sealed class? So a sealed class means it cannot be derived, right? So it cannot function as a base class. So interface. So what is an interface? It's a collection of abstract members, right? We don't exactly we don't write the body of when we declare an interface, or when we define an interface, we don't we just mention the abstract members like the function names and things like that. We don't really implement it. The deriving classes do that, right? So we also know that since C# does not support multiple inheritance, interfaces can do that, right? So the CTS allows a class to implement any number of multiple interfaces. In fact, any number of interfaces. Then we have CTS structures. So this is pretty much the similar structure that we all saw probably when we did the C programming. We have parameterized constructor, and those are those are the constructors which have parameters. That's it. So all structures are derived from a common base class. So which is that base class which all structures inherit? So what do we know about structures? They are either value type or reference type. So we all know that structures are value type, correct? It's on the stack. So the CTS permits structures to implement any number of interfaces, but structures may not become a base type, correct? So that means to say that that is why we have classes, right? Structures, we cannot inherit structures. So that is you do not have inheritance for structures. So here it is. So that's a simple structure. Struct point. This is point x, point y, and we have a display. Console.writeLine. This is 0 and 1. That stands for this and this value, variable, in fact. Okay. And that's that. Okay. Next comes interface. So that's an interface. You can see it's just a contract. It's a contract wherein we just have the function definition here, the members, and the inheriting class will implement the interface. So then we have enums. So we all know about enums also. It's a name value pair, just like this, right? We can use it for different purposes. Then we have delegates. So what is delegates? It's a, you can see that it's the .NET equivalent of type safe C style function. Okay. So we are not really going into the depth of delegates, but probably you can take a look later when we program. So that's the summary. Delegate is like C's function point, okay, wherein you can trigger a particular event based on a particular action. So now quickly let us go, since we have finished our discussion on CLR and CTS and CLS. Let's quickly go through the differences between so CLR CTS is common type system, CLS is a common language. Then next is it describes how it describes how types are declared, used, and managed in the runtime. So it is a specification that defines the rules to support language integration in a way such that the programs written in any language can yet interoperate and with one another and take advantage of inheritance and all that. Okay. So power of CTS. Now you will see this also in an example later. Well, anyway, I'll read it. CTS is a superset of CLS. CLS is a subset of the CTS. So we'll take a look at this example in the next slide. Okay. So before seeing that, these are the intrinsic CTS data types. System.byte, sbyte, int16, 32, long, you, this, all this, this. Okay. Understanding the CLS. So understand is a set of rules that is, so what is the CLS? So the CLS is a set of rules that describe the small and complete set of features. It is supported by the .NET compiler to produce code that can be hosted by the CLR, and it can be accessed by all languages, that we should be aware. Then it can be viewed as a physical subset of the full functionality. It can be viewed as a physical subset of the full functionality of the CTS. So what else? CTS is a set of rules that compiler must conform to if the products or the apps in which if the apps are to function in the .NET world. So now take a look at this particular example. Unsigned. Exposed unsigned data is not CLS compliant. Okay. So you can see that. So this is internal. So this is local. That's fine. But since this is returning an unsigned long, if this is returning an unsigned long, it is not CLS compliant. Okay. That's what they say here. So since this is unsigned long, no problem. we are still CS compliant, though we are using unsigned. That doesn't mean to say we are okay. So this cannot be, this is not called by anybody. This is not unsigned. Okay. So what do we do to ensure CLS compliance? So it does not, if it is not CLS compliant, we have programming construct that are not CLS compliant, but so we can instruct the C# compiler to check for CLS compliance. Okay. So the last of the three building blocks of the CLR, we have gone through this in bits, but let's do it once and for all. Okay. First of all, the runtime. It is a collection of services, and the .NET runtime compiler is shared by runtime layer. Sorry, is shared by all .NET languages. So, and this we know that CLR is the heart of the heart of CLR is named we have an assembly called the heart of the CLR assembly is called, we have an assembly called the Microsoft Common Object Runtime Execution Engine, NS Core EE. Okay, so that's the basic assembly. So what else? We have the runtime lays out the type in memory, compiles the associate CIL, performs any security checks, and resolves location of an assembly. So that is what we have. How .NET source code is compiled. Compiler, it converts into a CIL. Then we have the base class library, MS core lib.dll, the class loader, just a jitter, then platform specific code finally. Right? So let's take a look at .NET namespaces. So what do we have? What does it say here? Any language targeting the .NET runtime makes use of same namespaces and same types as a C# developer. Okay, so we can semantically group related types, classes, enumeration, this under the same umbrella. System.io for file IO, system.data for database, things like that. Right? So here's a sample, this one. So the system namespace provides a core body of types that you will need to use as .NET. So you can see the system namespace. So you cannot build any sort of functional C# application without making reference to the system namespace. We should also keep in mind that it's the root namespace for many other .NET namespaces. So that's a small snippet of code. you can see here, each language is making use of the console class defined in the system namespace. You can see this is VB, but even if it's C# also, you will still find the console namespace. Okay. So these are the other namespaces that are in existence. There are almost many others. So accessing a namespace programmatically. Okay. So in C#, the using keyword simplifies the process of referencing types defined in a particular namespace. So when, like say in a traditional disk application, we can include any number of namespaces, like all these, right? So you can see that this is system.drawing. So now we know that, let's say for example, we have to correctly use the namespace. Now, since this application is referencing system.drawing, the compiler is able to resolve the bitmap class. Okay. So this is how it is. We can use system also. We can simply use bitmap also. We know that since this is using this system.drawing. If this was not there, then we probably would have to use this one, the whole namespace, correct? So these are the namespaces, some of the namespaces. We have already seen some of them here. This is just in a table that I took. System primitive types, garbage collection. So you don't need to, even if you say using system everything, all this is, you get all this. System.collections, all these things. System.data, common NoDB, SQL client for database manipulations, IO for file IO, drawing.2D for bitmap fonts, icons, system.threading. Okay, so that is about bitmaps and namespaces. Okay, so let's, with that we'll stop our C# class for today.